Hi, good morning. I think this morning too many problems.
Yeah, that's why I thought where's the link, teacher? Whether
Too many problems. Next, I need
Ah.
to take my computer to do some repair already. Okay, let's go to structure question. Okay, let's go number 1. Write down the stationary wave is represented by the equation. Write in terms of variable in the equation above. Represent the frequency. So what is the frequency? Yep, how to guide the frequency?
Frequency equals to 2 pi over lambda.
Right? You must remember this formula. Omega is 2 pi f. So f is omega over 2 pi. Then I put a question mark. I think your answer give wrongly. How to calculate the wavelength? Yeah.
2 pi over k.
Good. 2 pi over k. Explain whether dy dt represent the velocity of the wave. Yep. Dy dt. Is it the velocity of the wave?
No.
Then what is it? What is dy dt?
Velocity of particle is in its vibrational motion.
It's the velocity or the speed of the wave. It's not the speed of the wave, it's the speed of the oscillating particle in the vertical direction. Right? You need to say no, not say no. Explain means you have to tell why. A stretch string is tied at one end of its end to a wall. The free end is vibrate to produce a stationary transverse wave in the string. Explain why stationary wave and not a progressive wave is produced. Yep. Explain.
Yeah, okay. Wave reflected from the wall.
That's all.
Superposition of two progressive waves of the same frequency and amplitude but traveling opposite direction produces a standing wave.
You must learn to apply here, not just memorize answer. Here, when the free end is moved up and down, you send the wave down. At the wall there is reflected, so the incident and reflected wave interfere. That's what you should do to produce standing wave. Right? When the free end is vibrate, it sends progressive wave along the string. At the wall, the progressive is reflected. So the incident and the reflected wave have the same frequency, amplitude, and traveling in opposite direction interfere to produce standing wave. Right? You must explain it fully. If the separation between two neighboring nodes is 30 cm and the velocity of transverse wave in the string is 150 cm per second, what is the frequency of the wave? Okay. How to find the wavelength? Okay, you must know roughly. Imagine how the wave is formed. Yep. How to find the wavelength? I can see you didn't do your homework. Right? How lambda? You should be able to read. I'll give you the picture already. You look one side. This is a symbol for this graph represents standing wave. Right? Look at one side. There's one whole wavelength. So between node and node is your half a wavelength. So lambda is 60 cm. And after that, frequency is speed over lambda. Put in your value 150 cm per second. Right? Lambda is 60 cm. So if you use cm, then you will get your answer in cm in hertz. Cm and cm will cancel. So it's 2.5 hertz. Okay. Any comment? No, let's go number 3 then. The equation of progressive wave is y equals to sine 2 pi 40 minus 0.2x. X and y are in meters, t in second. What's the amplitude? Okay, what's the amplitude? Why so slow? Didn't do your homework, that's why I can say. What's amplitude?
And 1.0 meter.
Just read here. Amplitude is the front here. 1.
Yeah, 1.0.
And what's the wavelength?
5.
Use your formula and work it out. No, this will be easy.
4 equals to 2 pi over 4.
Lambda is 2 pi over, there's a 2 pi there, times 0.2 and 5.0 meter. How to find the speed? How to find the frequency?
Frequency 2 pi f equals to 8 pi.
Pi f omega. So omega I get from here 2 pi times 4. So 2 pi, take it down, you get your f. 2 pi times 4, 2 pi here, 4 here, and divide by this 2 pi. 2 pi and 2 pi cancel, is 4 hertz. So how to find the speed? Yep, how to find the speed? Speed is just your frequency times wavelength. And see that you're not doing your homework. I don't know how you're going to progress. Right? Unless you are going to put in an effort to study, you are going to struggle through physics. I can be honest with you. That's why I keep on scolding you. State whether the wave is moving towards the positive or negative x direction. Yeah, positive or negative x direction. Why take so long? Negative sign straight away, positive x direction. Okay. Let's go to 3C. If 2 points A and B along this wave have a separated by a distance 3 meters, what's the phase difference between the vibration of A and B? Okay, how to calculate, what formula to use?
Phase difference.
Yep.
2 pi over lambda x. 2 pi x over lambda.
Yep. Lambda we have already calculated there. That's our lambda.
Lambda is 5.
So just using formula. Yeah, that formula. Take the 2 pi across there. 2 pi, 3 meter, 5 meter lambda. Calculate up. 1.2 pi radian. Okay. A standing wave is produced along a stretched string with a wavelength 4 cm by vibrating both ends of the string simultaneously. The length of the string is 12 cm. Draw the wave profile of the standing wave produced. This one should be able to do. Standing wave is produced along a stretched string with a wavelength of 4 cm by vibrating the end of the string. So number of wavelength. Right? You are told the wavelength is 4. The string is 12 cm. So you have to look at the number of wavelength. Calculate number of wavelength first. 12 divided by 4 is 3. So it means that there must be. Sorry, I've done something wrong. Sorry. Yep, that should be the way. That should be the answer. Right? 1 wavelength, 2 wavelength, 3 wavelength. So it means we should have 6 loops. Okay. What is the frequency of the wave if the velocity of the wave in the string is 5 cm? How to calculate the frequency? What formula to use? Yep.
Frequency equals to 50 over 4.
V over lambda, so V over 4, correct? 12.5 cm.
Hertz.
Right? Sorry, hertz, not cm. Draw a graph with the y-axis as a phase and x as the distance along the string measured from one end to show the variation of the phase along the string. Okay, all these will have one phase, all these will have another phase, right? So it should be all the same. The part C is just that's all, right? All of these at the top there, pi over 2, and here will be pi over 2. So the difference is pi radian. Okay. Ken, any problem? Okay, if not, let's carry on. Number 5. Okay, I think the answer they given is this one, they use 2.5 instead of 25. Right? So there's a mistake there. The displacement, distance x and time t of progressive wave can be represented by this equation. X and y in cm, t in second. State the direction of propagation of the wave. So what is the direction of propagation of the wave? Yeah.
Positive direction.
Positive x direction, good. Determine the velocity of the wave. How to determine? What should I do first?
2 pi f equals to 2.5.
Good. Calculate your wavelength. And calculate your frequency. And f times lambda. Okay. I want to take the f down. Take the 2 pi down to get your f. Right? This one, they take the lambda across, take the k down. K is 1.5. That's your k. Then this one, omega. Omega is 25. Right? That's your 2 pi. Then you can divide by 2 to write in terms of pi, or you want to calculate out. They want to calculate out because there is I can use a pi there to cancel it off, or you can calculate out whichever you prefer. So velocity is Vf lambda, right? 12.5 lambda. Sorry, F is 12.5 pi. Lambda is 2 pi or 1.5. Or as I say, you can calculate out and then the same thing. So that's your answer. 16.7 cm per second. Determine the velocity of the particle at a distance of 1 cm and time 0.5 second. Okay. Calculate out. What's the answer? Right? They give 1.7 because they use 2.5 here. This one. This one. Okay. Right? We have calculated the dt, the speed. Okay, which is this one. Determine the velocity. So that's the equation. This equation. Put in your value. Right? Right? This is the velocity of particle, not the speed. This is the speed of the wave, or velocity of the wave. Right? Differentiate it. Differentiate, you got the 15. And differentiate this one. Right? In terms of t, 25. Differentiate this one, 25 dx dt. Then the sign there becomes a cos. Right? All this the same. And put in your value. Right? This one is the same. Dx dt is this one. Cos 25. And then your time is 0.2. Your 1.5. This is 1 cm. Right? If you use cm, then it's all in cm. You're all in cm, so it doesn't matter. Then remember, these are all in radian. Right? Radian. Okay, answer is different because, as I say, they use 20. They use 2.5 here. Doesn't matter as long as you know how to use it. Okay with that? Anything not clear?
So far, okay.
Let's go to essay question. You can try the others. Don't know, you can ask me. Let's try an essay question. After that, we take a break again. Distinguish between transverse and longitudinal wave. Okay, how to distinguish? Yep.
Transverse wave, oscillation perpendicular to the direction of wave propagation. The longitudinal one is parallel. That's the difference.
Okay. Transverse wave, the vibration or the displacement of the particles are perpendicular direction of travel. Longitudinal wave, vibration of particle are parallel to the direction of travel. Okay, transverse wave, travel along the stress string. The displacement of a point O is given by the equation. The speed of the wave in the string is 6 cm per second. Find the frequency. So how to find the frequency? Yep. And wavelength. How to find the frequency? Yeah, from
2
here.
pi f equals to 4 pi.
2 pi, omega is 2 pi f. Then your frequency is omega over 2 pi. Right? Omega is 4 pi here. There's omega. Right? Divided by this 2 pi. So you got 2 hertz. How to calculate the wavelength?
Wavelength V over F.
Right? V over F. Put in your V. That's your V. That's your F. That is 3 cm. Write down the expression for the displacement Y with time t of a point P. Yep. How to write? Write down the expression for variation of displacement Y with time t of a point P. Yep. Any idea?
One B. No.
Okay, you are told that P lags Q by pi. Then calculate your phi. Wait, what am I doing? Have I done something wrong here? Find the frequency and wavelength. What am I doing here? Let me just check what am I doing here. Oh, I'm doing part 1 only. Now I'm doing part 2. Okay. So part 1, I've already got the answer. Okay. Write down the expression for the variation with, okay, a point P, a distance x to the right of O. Okay, calculate your phi. You are told the distance x is 2 pi x over 3. Write down the equation. Okay, there's a general equation. Omega, we already calculated, is 4 pi from the previous question. Right? There's a 4 pi there. There's a displacement 2 pi x over t. Okay with that? If x is 1.5 cm, determine the displacement y at 0.2 seconds. You have to know part 2 first before you can do part 3. And put into your equation the value of x. Remember, all these are in radian. Calculate out. Okay. Calculate the maximum transfer speed of the point P. Okay. Right. Can use that equation rather than differentiate it. This is faster. A times omega. A is the amplitude. The amplitude is 5. Omega is 4 pi. Right. Refer to your previous working. Sketch the graph of displacement distance graph of the wave at time t equals 0 and t equals 0.2. Okay, so that is your equation. At time t equals 0, right, you want displacement distance graph. So put your t equals 0 here. That's what you get. 0.2 seconds, same thing. Put into here. Right? Okay, how far has traveled? Okay, your answer is a bit wrong. You put 3 instead of 6. Right? V is here. T is 0.2 seconds. So that is your, this one is a sine graph, right? Negative sine graph. And then this is 0.2 seconds means 1.2 cm. Right? That distance there between the two is 1.2, or this distance between these two is 1.2 cm. Okay with that? Any comment? Okay, if there is no question, we will stop here and then we will start a new Zoom. Give you a time to stretch yourself. If you haven't done your worksheet, you better do it now.
There's another 5 more minutes.
Doesn't matter. No point in
The half an hour thing. 5 more minutes for the half an hour thing, teacher.
Oh, then we might as well use the 5 more minutes rather than stop here.
10:45.
Okay, we might as well use another 5 minutes and try to solve as much problem as possible. Okay, let's try to do number 2. By referring to wave, explain the meaning of amplitude and frequency. Right? What's the amplitude?
1 minute. What's the amplitude? The maximum distance of particles in the medium from the equilibrium position.
Okay, from the rest position. Good. Frequency?
The number complete of oscillations per second for particles in the medium.
right? Number of complete oscillation per second of a particle of the medium as the wave pass through. Explain how in practice a stationary wave is produced in a stretch string. Yep. This is the condition. When you're asked to explain, you are just stating the condition, that's all. Memory work. Yep.
And the wave profile of a standing or stationary wave does not move in the direction of wave propagation.
How to produce it? Didn't ask you what is stationary wave. Right? One end of the string is stretched.
Is produced by the superposition of two progressive waves of the same amplitude and frequency traveling in different direction.
Yeah. Right? Superposition of two waves traveling in opposite direction of same speed, same amplitude, same frequency. Okay, how do we produce it? We attach a string, one end to the wall and the other end to a vibrator. Vibrator sends a progressive wave on the stretch string. The reflected wave from the attached end and the incident wave interfere, produce standing wave. Frequency of vibrator is adjusted until the loop is observed when the standing wave is formed. Right? For higher frequency, you have two or three loops. Right? The key important point is the two must have the same speed, same wavelength, and traveling in opposite direction. Okay. The graph refers to a wave of amplitude 4 cm. Graph shows the variation of displacement with distance in the direction of motion of the wave at a certain instant. Graph 2 shows the variation of displacement with time in a certain point. Okay, how to calculate the wavelength for the first one? What is the wavelength? Yep, that's the wavelength. Why so slow? Didn't do homework.
Wavelength is 2.0.
Just read only. From here to here, 2 cm. What is the frequency?
12.5.
Why 1.5?
12.5 hertz.
Why 1.5 hertz?
I said 12.5, teacher.
12.5. How do you get 12? How do you get 12.5?
1 divide 80 times 10 to the power -3.
Okay, you can do your own way. 80 equals period also can, or 40 equals half the period. So you get 80 millisecond, 1 over 80, right? 12.5 hertz. How to calculate the wave speed? Yep.
Wave speed, V equals to 12.5 times 2.0, V equals to F lambda.
Right? V equals to
F lambda.
F lambda. Put in your value. Right? Your F is that one. Your lambda. Lambda we have calculated. Yeah, that one there. You put cm, then your answer will be cm. Then the displacement at time t equals 0, this one. Okay. There are various ways of calculating it. It's up to you. You can use cos, you can use sine. What I did is I concentrate on here. That one there. And then know this time. So that height and that height is the same. Right? So that's why I'm using sine. You can use cos and concentrate on here if you want to. Okay. can use cos or concentric. I'll use this time, no? Same thing. Right? So I use this one. Amplitude is 4. Right? That's your 4 millimeter. And then 2 pi x, 2 pi. 2 pi times 12.5 t. Right? I'm using this part. 2 pi f. F is what we have calculated here. That's your f, 10 times t. And put in your value. Right? I'm just calculating at this point, which is 10. 10 is 0.01. So I get 2.83 millimeter. Okay. Can? Okay, we might as well stop here. Give you a short
Yeah.
break. Then we will mark your worksheet. Anything else to ask? If not, I will stop here.
Yeah, stop here.
If you haven't done your worksheet, then you better do your worksheet now. Okay, we stop here.